Hello. Today we will go over a brief introduction of what are circuits and how they affect us in our everyday lives. So we will learn today basically what are circuits as well as the different types of circuits, because there are multiple different types and it's important to decipher which one is which. We will also go over what is a breadboard and how we will use it to create a circuit through an online app called Tinkercad. And at the end of this, we can be able to create and simulate various types of circuits. Let's get started. So basically, a circuit is a path for electricity from a power source, like a battery or a wall plug, to power on electrical devices like LEDs and motors. And every circuit must have a source of power, most commonly being voltage. We will most likely be using 9-volt batteries whenever we make circuits. So there are two different types of circuits, one of which being direct current, also known as DC, and an alternating current, also known as AC. So alternating current circuits are circuits powered by an alternating source, either current or voltage, and the amount of the current or voltage will change periodically and will each have an average value. AC powered devices that you can find around you are lamps, washing machines, refrigerators, a lot of stuff that requires a lot of power. And these and alternating current can be found most commonly in the power grids beneath us, and wall plugs use AC. So yeah, that's how you find where alternating current exists in your life. Direct current, also known as DC, consists of a power source like a battery and one or more loads. Now, what are loads? Loads are electronic devices that will absorb electrical energy from batteries and such, and would convert them to a different type of energy. Like an LED would convert the electrical energy from the battery and convert it to heat energy. And a motor will convert electrical energy to mechanical energy. And DC circuits are a closed path for direct current from the battery to flow in one direction. So it has to be closed. There has to be a connection from point A to point B. And DC circuits are used for more low voltage applications than AC circuits will. Some of these applications include phones, flat screen TVs, and flashlights. And if you notice through both of the graphs, you can tell that the voltage is going a little bit high, a little bit low, a little bit high, a little bit low. But DC, the voltage is the same throughout. Both of these are very useful through their own applications. So, how will we make a circuit? We will make a circuit through what is called a breadboard, and essentially these are small little plastic rectangles that allow us to place electronic components inside these little holes by plugging them in, so we can create electronic circuits. And essentially this allows us to create circuits because a breadboard contains a bunch of these tiny little strips of metal. So if we plug in a wire to row 1, and we plug in another wire there, it will allow the connection to continue. Think about it like it's a stepping stone, but you still have to plug in all of the wires and batteries and all of that jazz. So now that we know what a breadboard is, what circuits are, we are going to go over some electronic components that we'll be using in an online app that will allow us to create circuits. So battery should be straightforward. It's a device that stores chemical energy and converts it to electrical energy. And our DC circuits will not work without an electric source. So it's very important that we have one of these, and we're going to be using a 9-volt battery for a bunch of reasons. One, it's probably the most common when making these kind of circuits. 2, it produces a lot of voltage for its size. And 3, Tinkercad uses this type of battery the most. A push button is an electronic device, also known as a load, that is pushed to operate an electric device. What makes it unique is probably from the graph right here. It has a strip of metal, and when you push it down, it makes a connection from one wire to another wire, thus creating a connection whenever you interact with it. Some examples of this would be keys on your keyboard, as well as electric doorbells. A DC motor is another electronic device in load that converts electrical energy into mechanical energy. This works by using the forces produced in a magnetic field to create a churning motion. So if you wrap a wire around a magnet and you put current through it, the wire will move, and this is called the motor effect. A switch is very similar to a push button, except rather than creating the circuit whenever you press a button, it will create a circuit when you press one side of the switch once. So these are loads that can make or break a circuit, and let's say you were to press the switch, it will rotate and push a little trapezoid looking wire to change the connection from the left and middle wire to the middle and the right wire. And light switches are a good example of where you can find this in real life. An LED is a light emitting diode that is a load as well as a semiconductor device, which will emit light when electric current goes through it. So you can find this anywhere that has light, you would find this. A resistor is another electronic device in load that will limit and regulate the flow of current in a circuit. And it's very important to have one of these alongside an LED when creating a DC circuit, because if you don't have enough resistance, an LED will blow up and you'd have one less LED than you would want. So there's all kinds of different levels of resistor, and they're all measured in ohms. And how you would solve this is through an equation known as Ohm's law. And in order to solve how much resistance you need, you would divide the voltage from your power source. So if you had a 9-volt battery, it would be 9 divided by the amount of current inside your LED, for example. So let's say you had 20 milliamps. That would be 9 volts, so 9 divided by 0.02. So I can find a calculator online. Ohm's law calculator. I see, yeah. Let's say you had 9 volts divided by 0.02. Calculate. So you would have 20 milliamps, 0.02, 9 voltage, 9 divided by 0.02 would be 450 ohms. So a potentiometer is another load that will adjust the resistance of your electronic component. This does it by, it has a little knob that you rotate, and as you rotate it, the potentiometer has a bunch of different resistors inside, and when you rotate it, it increases the amount of resistance. So it would be either, so it can be used for adjusting the speed of a motor as well as adjusting the brightness of an LED. So now that we know everything, we will go on to a website called tinkercad.com. So I'm just gonna log out for a second. So if you haven't created an account already, you should see this window. So then we'll sign up, create a personal account, and you'll sign in with Google. But I already have an account, so I am just going to log on. Okay, so let's create a circuit. We're going to be making DC circuits because I may have explained this before, but any low voltage application, you would always use DC circuits. Unless you're building something very big like a fridge. So we are going to start out with grabbing our breadboard. This is Tinkercad has a little pop-up menu down here, which has all kinds of stuff. It has like microcontrollers, it has electrical components, it has a lot of stuff to work with. What we're going to start out with is to make a motor go forward by connecting it to a battery. So what we're going to do is we're going to connect the battery to both of these ends of our breadboard. Next, we will grab a DC motor. Should be the little hexagon looking thing and the pop-up on the right. Next, we're going to create a wire. You would do this by clicking on any terminal on electrical devices like a DC motor, and we're going to connect the red side to the red row and the black side to the black row, because a positive side of the battery is always going to be the red side, and the negative side is always going to be the black. So after we solve this, we're going to click in the top right corner, start simulation. And as it shows us, we have a motor that is spinning. I'll delete this. Now, if we switch to wires, we can go see what happens. Let's make it so the negative side of the battery touches the positive side of the motor. And it's going counterclockwise. This is because since electricity flows from one direction, only one direction, you can change making the electricity will go reverse direction will reflect a motor going reverse. Now, let's do something a little more advanced. We will connect a wire from the positive row to column 1, and then connect another wire from column 1 to the red wire, to the positive side of the battery. Next, we will connect from the negative side of the motor a wire from that to column 3. Next, we're going to add a push button. We are then going to connect the second leg of the push button to the negative side of the battery. And when we start a simulation, it should see, when you click the button right here, the motor can be going. And when, let's say, we unclick, it stops. So let's change this up a little bit. Instead, I'm going to move it. Stop simulation. We're going to delete the motor and the button. Next, we're going to be messing around with some LEDs. I'm just going to reverse this side. To start off with, make sure you connect a wire from the positive side to the lightning bolt shaped end of the LED. Next, we're gonna connect a resistor. I'm doing 1000 ohms just for simplicity. And then we're going to connect a wire from, nope, never mind, we're not connecting a wire. We're going to connect a push button from the resistor to the negative end of the battery. So when we push the button, it'll light up. Next, why don't we take away the push button and add a little slide switch. So when we connect this to this, we create a simulation. Hit start, slide, turns on, slide off, nope. Now, let's add a push button to it. And then we'll move the wire here to here. And let's start it again. let's say I slide it to not create a connection. If I push a little button, it's not going to work. See what happens when we add a motor rather than an LED. Start it up again. Switch on. Switch off. Let's remove the resistor and see what happens. Start it again. So now it's going at full power. Resistance also affects motors as well as LEDs. So resistance is in everything electronically. Now let's go on to a project that I've already made. We are going to, so we have a potentiometer that is connected to the negative side of the battery and is also connected to the negative side of an LED. The second leg of the potentiometer is connected to the resistor, which is connected to the positive end of the LED. And the last leg is what powers the potentiometer. So if I start the simulation, and I crank the dial, it will get brighter and brighter. And if I crank it down, it'll get less bright and less bright. So that is all. Now you know how to create circuits on your own on Tinkercad, and you have a better understanding of everything around you.